Hello, my name is Yossaphan Kaenwong. My student ID is 65364084. So in this video, we will introduce network layer 1 of 2. So the objective, we first discuss service that can be provided at the network layer, packetizing, routing, and forwarding. We then discuss the network layer as TCP/IP suite, IPv4, and ICMPv4. We also discuss IPv4 addressing and related issues. We then concentrate on the unicast routing and unicast routing protocols. We then move to multicasting and multicast routing protocol. We finally discuss the new generation of network layer protocols, IPv6 and ICMPv6. So in this picture is the communication at the network layer. So in the network layer is linked across by data link and physical by the router. Network layer service. Before discussing the network layer in the internet today, let's briefly discuss the network layer service that in general are expected from a network layer protocol. Packetizing, encapsulating the payload in the network layer packet at the source and decapsulating the payload from the network layer packet at the destination to carry a payload from the source to destination without changing it. Routing, responsible for routing the packet from its source to the destination, finding the best one among these possible routes. Forwarding, routing, applying strategies and running some routing protocols to create the decision-making tables for each router. Forwarding, the action applied by each router, decision-making table, forwarding table, and routing table. Error control, the packet in the network layer may be fragmented at each router at a checksum field. Used an auxiliary protocol ICMP. Flow control, no error control. Congestion control, the number of datagrams sent by source computers is beyond the capacity of network or routers. Some routers may drop some of the datagrams. Quality of service, multimedia communication, providing better quality of service to support these applications to keep the network layer untouched. This provision in the upper layer. Security, the network layer designed with no security provision to provide security for a connectionless network layer. Another virtual level that changes the connectionless service to a connection-oriented service. The virtual layer is IPsec, IPsec. And this is the forwarding process. Packet switching. From the discussion of routing and forwarding in the previous section, we infer that a kind of switching occurs, that the network layer, a router in fact, is a switch that creates a connection between an input port and output port. Just an electrical switch connects the input to the output to let electricity flow. The connecting device in a packet switch network designed to route the packets to the final destination. Two different approaches to route the packet: datagram approach, the vital circuit approach. And this picture is a connectionless packet switch network. Datagram approach is a connectionless service. Each packet independently having no relationship to any other packet. The network layer is delivery of packet from the source to the destination. The packet in the message may or may not travel the same path to their destination. And this picture is the forwarding process in the router when used in a connectionless network. And this picture is a virtual circuit packet switch network. And this is a forwarding process in the router when used in a virtual circuit network. And this is a sending request packet in a virtual circuit network. This is a sending acknowledgement in a virtual circuit network. An acknowledgement packet completes the entries in the switching tables. And this is a flow of one packet in an established virtual circuit. Network layer performance. The upper layer protocols that use the service of the network layer expect to receive an ideal service, but the network layer is not perfect. The performance of a network can be measured in terms of delay, throughput, and packet loss. We first define these three terms in a packet switch network before we discuss the effects on performance. So in delay is have a transmission delay, propagation delay, processing delay, queuing delay, and total delay, throughput, and packet loss. So the throughput in the path with 3 links in a series. In the path from source to destination, a packet may pass through several links or networks, each with a different transmission rate. How then can we determine the throughput of whole path? And this is a part of internet backbone. The actual situation in the internet to access networks and the internet backbone, the minimum of TR1 and TR2. So the TR is transmission rate. And this is an effect of throughput in sharing. A router may collect a flow from several sources of distribute the flow between several sources. The transmission rate of link between the two routers is shared between the flows. The transmission rate of main link in the calculation of the throughput is only 200 kb per sec. Network layer congestion. In chapter 3, we discussed congestion at the transport layer, although congestion at the network layer is not explicitly addressed in the internet model. The study of congestion at this layer may help us to better understand the cause of congestion at the transport layer and find possible remedies to be used at the network layer. Congestion at the network layer is related to two issues: throughput and delay, which we discussed in the previous section. Congestion control is have an open loop and closed loop. So in the open loop congestion control is the retransmission policy, window policy, acknowledgement policy, discarding policy, and admissions policy. And another is the closed loop congestion control. It have a back pressure, show packet, implicit signaling, and explicit signaling. And this graph is a packet delay and throughput as functions of load. And this picture is the backpressure method of evaluating congestion. And this is a show packet, a packet sent by node to the source to inform it of congestion. The warning is from the router directly to the source station. The intermediate nodes are not warned. Example is ICMP. Structure of a router. In our discussion of forwarding and routing, we represent a router as a black box that accepts incoming packets from one of the input ports. Interface use a forwarding table to find the output port from which a packet departs and sends the packet from this output port. In this section, we open the black box and look inside. However, our discussion won't be very detailed, and Thai books have been written about routers. We just give an overview to the reader. So in the component, it have an input port, output port, routing processor, and switching fabric. And the switching fabric is have a crossbar switch, banyan switch, and basher banyan switch. Like this picture is the router components, and this is an input port, and this is output port. This picture is a crossbar switch. A crossbar switch connects N inputs to the N outputs in a grid using electronic micro switches at each cross point. Banyan switch, a multi-state switch with micro switches at each state that route the packets based on the output port represents as a binary string. So in these two pictures is the example of routing in a banyan switch. It have n inputs to and n outputs. And this picture is a basher banyan switch. So in the summary, the internet is made of many network or links connected or connecting devices, each of which acts as a router or as a switch. Two types of switching are traditionally used in networking: circuit switching and packet switching. The network layer is designed as a packet switch network. The network layer supervises and handling of packets by the underlying physical networks. The delivery of a packet can be direct or indirect. Two categories of forwarding are defined: forwarding based on the destination address of the IP datagram, and forwarding based on the label attached to an IP datagram. Thank you.